Okay, greetings everyone. Happy afternoon, good morning, depending on where you live. My name is Adam Greco, and I work for Search Discovery, and I head up the SDEC. I can't believe it, but this is our 12th SDEC session already, which is great. And I'm really excited for today's because we actually have a day-to-day analyst out there, someone who works on the client side, who's a member of the SDEC, who is graciously taken the time to come share some of the things that he's learned and done with Adobe Analytics. Frederik, Werner, he'll explain kind of who he is and his background, but I just personally want to say, as someone who has blogged a lot about Adobe Analytics, I have just been blown away by how much content he has been able to put out there and some of the really cool concepts that he's done. So Frederik is a man after my own heart. So if you have any questions during the session, if you have a technical issue, please use the chat area and I will post the replies there. But if you have a question that you want answered at the end of the session by Frederik, please put it in the Q&A area. If you put it in the chat area, I'm going to just tell you to go put it in the Q&A area. So thank you so much for joining. And Frederik, I will hand it off to you.
Yeah, thank you so much, Adam, for the introduction, the invitation, and all those nice words. I'm actually quite flattered, and welcome everybody to this session. So I'm Frederik, and we're going to talk about today what Adobe Analytics has to offer in regards to statistics, time series analysis, and forecasting, as you can see on the slide. And what you can actually see right now is something that we're going to build in this session. So let's just get started with the agenda for today. And this is it. First, I will take a minute to just introduce myself and explain why I personally love statistics as much as I do. And after that, we will dive right into the world of statistics to help us describe a time series data. We will count outliers and get our hands dirty with some advanced regression analysis. And to round things off at the end, I will give you a teaser on what is possible in terms of forecasting before we come to the wrap up in the end. So this is me. I'm Frederik, and I work at SuperRTL in Cologne, Germany as a digital analytics lead. I've been doing analytics for over 10 years now, the last 5 of those with the Experience Scout products, especially Analytics Target and Audience Manager. However, I started as a backend web developer, which I think still influences how I tackle some challenges in analytics today. So for example, when I'm looking at calculated metric functions or tools in analytics, I always see them as building blocks for whatever I might want to build in the future and try to understand how they work on the inside, not so much look at the current application. So anyway, during the last years, I did more and more data science stuff, currently building our data platform at SuperRTL. And as Adam already mentioned, I also blog and do this at fullstackanalyst.io. And that name already indicates that I'm blogging about basically everything related to digital analytics, not only about Adobe Analytics, but also some open source tools like Snowplow or Elasticsearch. And in regards to Adobe Analytics, you can, for example, find posts about how to do a next and previous page report within Analysis Workspace, how to get organic Google search keywords into analytics, or how you can combine different KPIs from different report suites without a global report suite, so an additional cost. So feel free to check that out anytime. And I've also created a secret page on that blog at fullstackanalyst.io/SDIC, where you can find all the posts about this topic, some helpful links to the Adobe documentation and instructions on how to follow the content on the blog. And I've put this QR code here for you to scan, but don't worry, I will put that up again at the end of this session. So enough of that, let's start with the actual interesting content. And first of all, I want to tell you why I love statistics so much. And I think I need to start this off with a little information about myself, because I don't have any academic background in, say, business studies or computer science, because I'm actually a clinical psychologist with couch and everything. And while I was still studying psychology, I came to know that statistics is the only real way to learn anything about larger groups of people. And while it was fun and very rewarding to spend time with patients in a one-to-one setting, we would always need to go to statistics if we wanted to talk about populations as a whole. Once I ventured then into digital analytics, I quickly discovered that statistics can be a very helpful tool to reduce the cognitive load on our business stakeholders if they, for example, ask for a performance report. And I've actually put an example here on the bottom, because those numbers on the right here basically include everything that a typical stakeholder would want to know, like the average visitors per day or the fluctuations in traffic. But he doesn't have to look at this very detailed graph and having to do kind of the mental math themselves, because in my day-to-day job, I find this quite often that my stakeholders would just look at this graph and then start calculating exactly those KPIs in their head, which they wouldn't even need to know. So how do we build this exact view? We're going to start this off with this simple graph and freeform table, which I think every one of us has built somewhere in their career. And it gives a very nice performance overview, but makes it quite hard to judge the performance at one glance, because we always have to look at this detailed graph or table. So we are actually going to help our users by adding some summary columns to this very bland table. And to get started, we are just going to right-click our unique visitors metric in Workspace. This will present us with this very neat context menu on the left. And from here, we can just click create metric from selection to see quite a bunch of options for new metrics we can create on the fly for this workspace. And the one thing that I do love most about Adobe Analytics, because it just allows us to create those metrics so fast, and just allows everyone to create those. And for our use case, we are going to select the mean here to just add a new column containing the mean of unique visitors like this. And in this new column, we can actually see how this function works quite nicely, because it just outputs the same value in each row of data as well as in the total row. So I find this very helpful in describing our data. So we're going to just keep this and use it on our final dashboard already. So it would be very nice if we had a way to summarize also the daily change in our data, so this fluctuation here. And luckily, both statistics and Adobe Analytics have us covered there, since we can just use what is called the standard deviation for this. So in Analytics, we can just go to the calculated metric builder and look at this function here, which is called standard deviation. And it just tells us in which range the majority of our data is relative to the mean. There's only one slot for us to fill here with the metric we want to have summarized. So I already put unique visitors here. And if we just save this and drag it into our table in Workspace, we can see that it does exactly what we wanted to do. Because this new column now tells us where the majority of the data points are, and it's always relative to the mean. So to put it a bit differently, we are measuring just our daily traffic fluctuations, so this range here. And as you can see, it's also a constant value across all the rows in our table. And this line down here shows where it goes over time. But we are still going to make it a bit easier for our stakeholders. So we're going to create two new metrics here. This time we're going to use the right-click context menu again, but we are going to select two of the metrics, both the mean and the standard deviation. Now we have some different options here. Because what we can do now on the fly is just add and subtract the values from each other, which is what we're going to do to give us this very nice view right here. So those two new columns visualize quite nicely on our graph where the majority of our data is. So this is the lower range of expectation, this is the upper range. And again, I really love how quickly we just built this and how nice it looks on our graph. So we're also going to use this on our final dashboard. But there's still something that our stakeholders could want to know because they are very interested in the range of data, but from my experience, they are also very interested in those outliers. We can see here where the data actually goes above or below that threshold. So what we're going to do next is just count those outliers. And we have a very simple function for that as well, but it's well, put into the advanced function section in Analytics. So what we have here is the what is called a greater than function, but we also have a less than function to complement that. And what it does is just comparing the metric in the upper slot, the X slot here, to the one in the lower slot, the Y slot here. And it will just output 1 if it's greater in this case and 0 if it's not. So this is exactly what we need already. So we're just going to put this into our table. And what we're going to use is our unique visitors metric as 1. And then in our example, the upper boundary for the other metric. And once we put it into the calculator metric together, we can see it works just nicely. So now we have those two new columns, and we can just clearly see how we are able to detect outliers in our data with those metrics, since they just output 1 whenever our unique visitors are above or below our upper or lower boundary. So also, since I hope that maybe someone from Adobe might see this session, I'm just going to sneak in 2 feature requests. First, it would be very awesome if we could just filter our table by those metric values. So for example, we could just say greater or lower than 0 here. And if we could combine this graph together with our line chart, for example, as a bar chart in the background, that would also be very nice. But enough of that. Let's count how many outliers we do have in our data. And to do this, we are going to right-click those columns again, which will just give us this context menu where we can just select column sum, which will look at every row in a column and sum all the values together. And since we're always outputting 0 or 1, the sum of that always gives us the number of rows where we have those outliers. So this is how it looks like if we put it in our table, where we can now actually see that we have 6 days below our expectation and 5 days above. So all we need now is some very nice visualization, and I thought of something like this. So here I include just the original KPI, the mean and the boundaries for the upper and lower expectation on our graph. And then on the right-hand side, we have 4 summary number visualization for the total rows in our table. And first, we have the average of daily unique visitors. Next to that, I just quickly divided the standard deviation by the mean to give the percentage of daily traffic fluctuation. And below those, we have the number of days above and below our range of expectation. So I don't know about you, but I find this quite remarkable for the little time we have spent on this. So especially this graph gets me very excited because I just really like that kind of visualization. So let's just quickly summarize what we just accomplished, because we created a new calculated metric to summarize our data through the mean function, showing the average of our metric over time. And to give some feeling on how stable our KPI is, we added the corridor of expected values through the standard deviation. And with this range, we are able to detect and count any outliers. What we are now going to do is take this even one step further by using regression analysis. But first, let me show you why we need to do this. So in this screenshot, you can clearly see that our dashboard has a problem once our data is very strongly trended. This is of course because our mean does not care about any trends in our data, and it leads to this very high fluctuation and many days outside of the expectation. So we need something else to take this trend into account. Luckily, we can just do that by using the linear regression. What it gives us is a line of expected values that adapts to whether we have trends in our data or not. It does this by correlating our KPI to the x-axis, where we have the time in our case, and there's also a way to express the quality of our statistical model by looking at the coefficient of determination. So let's just quickly look at what Adobe Analytics can do in regards to regression. And here you can actually see all the different types of regression that are just readily available to us in Adobe Analytics. You can see the most common one, which is linear regression on the top left here. And you might also recognize this as the simple trend line you can add to a chart in Excel. But there actually are 5 other types of regression in Analytics for more advanced use cases. And the cool thing about analytics in this case is that it's actually not that much more complicated to use one of those advanced curves compared to the linear one. And also, since we can't go without it in 2020, we also have our exponential curve on here. So let's go a bit deeper and look at what our linear regression is actually made of. So this is a typical linear regression line. We see that compared to the simple mean, it does actually align with the trend over time, since it doesn't go perfectly horizontal. I've also put the formula on top here to show what we're looking at right now, which is the y part of the formula, so the actual regression line. But to get this, we also need this x variable, which in our case is just a counter that goes up over time. So it starts at 1 and then goes up for every day in the data. What you also have is the plus e part called the intercept, which is just where our regression line meets the y-axis. And we have what is called the slope, which is just by how much our data goes up for each day that passes. But luckily for our first example, we only need to create the x variable because we have a nice function in analytics that just gives us the y variable for that. But it does still need the x variable, so we can just create it like this. This is a function that we will find in the calculated metric builder called cumulative. And all it does is take the second value, which is 1 here, and add it for every row of data. So when we put in a calculated metric like this, you can see that it does exactly that. For each line of data, it just goes up by 1, which is exactly what we need as x variable because it just increases with each day passing. With those two new columns, we have all we need to get our y variable from the formula. And to do this, we of course need another calculated metric function, which is the predicted y function in the metric builder under the advanced section. So we just drag that in and we can see this mask here. So we got 2 new slots to fill. One for our x variable, which you can see on top, and one for the y variable. We already have everything we need in our table. So I just put everything in here with our incrementer variable on top and the unique visitors on bottom. So again, something I really love about analytics because it's just so simple to quickly build those really sophisticated metric. So we save this and drag it into our table, and we see it does exactly what we want. So instead of the rather naive mean, our line now literally goes with the trend and approximates our unique visitors just nicely. But to recreate our graph from before, now we also want to add our standard deviation again. But there's one small problem in this case, because our normal standard deviation from before is always relative to the mean. And as we discovered, we cannot really use that here because of the trend in our data. So this also means we need to recreate our standard deviation relative to this regression line that we just created. And fortunately, we can just do this as well, because this is a bit complex. I won't go into the nitty-gritty in this session, but you can just check out my post on that hidden page to learn how to precisely do this in analytics. But what we can see here is what we actually need to do. Because the part that we need to change in this formula for the standard deviation is just the mean here. And we already did the basics of that since we just put in our regression line, which we just need to put in here instead of the mean. So in this table, we see quite nicely how much more narrow to the actual data our new standard deviation here is, because the value is actually significantly lower in the second to last column compared to the last column with a normal standard deviation. So going back to our table, we just do the same as we did before and add or subtract this new standard deviation from the regression line this time, and we get 2 new columns here like this. So we just see how nicely our data is actually encapsulated by a new standard deviation around this regression line. And if we just have used the normal one, we had basically double the space here, and all our data would be encapsulated by this, which is not what we actually want. So again, I really like those kind of graphs. I hope you do too, because I get really excited whenever I see something like this. So But since we are using linear regression, we have quite a few neat tools to play with in addition to this. So let's head back to the metric builder and look at another advanced linear regression function. Because this time we're going to use the linear regression slope. So if you remember the explanation from before, this part of the regression equation shows us where our trend is headed. So by how much our regression line changes for each step on the x-axis. This function looks exactly like the predicted y one, so I'm not going to show it here, but just show you how it looks in a table. We can see that our new column on the right here works just as we expected, because both the individual rows and the totem of that column show very clearly that our regression line in the second column goes up by 16 for each day, which is a very helpful indicator in my view on our dashboard. Now we can see with one look that we are in an upwards trending time and are gaining 16 users per day on average. I find this very helpful, and there's still something more that we can explore in the metric builder. So going back there, we've also found there the correlation coefficient. So we know what correlation is, but just to quickly remind you, the correlation coefficient is a number between -1 and 1, showing how closely two variables move together with each other. If they both go up and down in perfect synchronization, they would also have a perfect correlation of -1 or 1, depending on just how they move. But we're not going to settle for this very easy view today, since there's something much cooler you can do with it if you already have the correlation. So all we need to do is square it, and we can do this right within analytics with a function like this. So what I'm doing here is calculating the correlation in this inner function here, which looks just like our predicted y functions, but I'm then wrapping this in the power operator. This is also why it's called R2 in statistics, and we would use a metric like this in a percentage format and just pull it in our table to see it alongside our data like this in this new column. So what does this tell us? By simply squaring that correlation, we get a very helpful and powerful quality indicator. It's called the coefficient of determination, and it's actually the number that tells us how well our regression model explains our actual data. So in statistical terms, it expresses the portion of predictable variance between our dependent and independent variable. And just as a rule of thumb, this value should of course be as high as possible and go down if your data behaves in an unpredictable way or does not fit the linear line very much. So now with all those columns in our table, we're able to build a very powerful dashboard like this one. What I've done here is just put my beloved regression line and corridor of expected values alongside those very cool summary numbers. The first and second one are quite familiar and just show the mean unique visitor and of special standard deviation here. And I didn't divide it by the mean this time to just show some of the possible variations. And below that, we have our regression slope titled just traffic growth per day and the coefficient of determination as the quality indicator. And I know I sound like an Adobe Analytics fanboy, but I just love how easy this is for me as an analyst to enable my users to work with a tool like this within Workspace completely on their own. That's very cool in my opinion. So let's take a look at what we just learned. We went through some evolution by starting with a quick and simple approach using the mean, and then went way beyond that as we learned that it's not quite adequate for trended data. With this knowledge then, we were successful in using the regression function, building our very own standard deviation in relation to that, and went even further by visualizing the regression slope and the R2 parameter in an understandable way. Not only was it understandable, but we also made it very clear how this provides value in our workspace. Now, to round things off, I have some special treat for you, because now we are looking at what might happen if we go too far with our regression. So what we just encountered here is that even with our very fancy regression metric, we can fail quite hard once we apply to future date ranges. So analytics makes no difference whether we have data to base our regression on or just zero values like here. And it will just happily pull down this regression line to match those zero values. What we need to do then is to actually create a regression line that is more like this yellow line here. So with this line, analytics does not take those dates without any data into account. To achieve this, we need to basically completely rebuild our regression metric with some segments to filter out future dates. But since we then need to calculate the future values, we can't just use the predicted y function, but we have to combine all our regression functions to rebuild the whole formula on our own. So if you want to know this in detail, I can just again recommend to go to my blog post, which you will find on that hidden page I'm going to show again in a minute. And the reason why I want to show this here is because this metric looks like this. So you can see quite clearly, of course. On the upper part, we're just rebuilding the slope, multiply it by our x variable here, and then at the intercept all on our own, also with some segments applied to filter out those zero values. And saying applied, one thing that I would also like to apply for is Adam's contest of the longest metric definition with this beauty here. And this brings me to my last sneaky feature request towards our Adobe overlords, because if we would just be able to click into this metric definition and had a way to copy and paste this from into analytics, I could just put this long string on my blog and everyone would be able to use it without having to resort to, for example, using the API or dragging everything in by themselves, which is very error prone. If you guys in chat also would like a feature like this, maybe let Adobe know in chat as well. So roundup time. Here's a QR code again, and it will stay up after the slide as well. I think I made a quite nice case for why building this in Workspace can provide a lot of value to our business, because there basically is no limit, at least that I know of, how complex those metrics can become, since we have all the building blocks there to go crazy with even the most complicated formulas. And building this in Workspace also means we can just share it, send it by email, use it with Report Builder or via the API for every tool we might want to use it in. So on top of that, we can just start playing around with it and explore our data within Workspace using other dimensions, calculated metrics, segments to really understand our users better. This is also what I answer to those few people who ask why I'm not building this in, say, R or Python or Excel, because I, as the analyst, may already have it there, but I need it to be where my users are and where I can distribute it in the best way possible. So also, I've assembled some tips on how to build a metric like the last one in a confident and efficient way. So I would just recommend to always make sure you know what you want to build first. And if you are familiar with other tools, you should also consider building it there first to have just a point of reference, because you can get lost quite simple when you're building complex metric like this. And then next to just start things off simple, preferably just right click in Workspace and start creating some metrics on the fly. You can then combine them to more complex metrics, and you're always able to validate your steps along the way. And besides that initial validation, you would also want to make sure you know how your metric behaves for different time ranges, granularities, or when looking at dates without data like the future. So the last point on this slide is one that is very close to my own heart, because I've been blogging for a while now, and it always has been the most fun if people just joined in, started discussing or talked about how they might use my examples. So I also feel like communities provide the most value if everyone just starts talking about their own experiences. And if you see an interesting post anywhere in any community, just go ahead, reach out to the people and just start talking, don't hesitate, and maybe share some of your own experiences. So that's everything I've prepared for today. Thank you all so much for joining, and I will now hand this back to Adam, as we might have some questions in the QA section.
Awesome. Well, Frederik, that was amazing. I feel like my brain hurts, which is always a good thing. And we've gotten lots of people who are chatting with us privately about how much they're loving your content. So we have a bunch of questions, but if you can, please go to the Q&A area now, and we will tackle as many questions as we can live, and then we will get to the other ones in written format afterwards. So I'll let you take a quick breath and then we'll dive in. So we have a bunch of questions that are related to a similar topic. So I'm going to give you two kind of general questions. Matt had said, we're interested in linear regression modeling in Adobe Analytics. We have different kind of traffic on weekends, which tends to skew our data. Is there a way to filter out weekends in your graphs and analysis workspace? And then while you're thinking about that, we also had a couple people say, at an even bigger level, how do we do what you're talking about, taking into account seasonality? So I think those are kind of a little bit related.
Yeah, so very good questions. So one thing that I did in the past was to just filter my tables in Analysis Workspace using the regression metric and then put on top of that metric the day of week or month of year dimension. So by doing that, you can actually see how your Mondays or how your Tuesdays are trending, or even how your weekdays compared to the weekends are trending and where they are going. So that would be my recommendation for that. And as always, seasonality is a kind of a hard topic in and of itself when you're using regression, of course. So what I generally recommend is try to just model the deviation that you have from month to month and include that into your model. But that's a very advanced question, I think, and I might write a post about that in the future. But in general, just look at that you always have a very large range of dates that you're looking at, and then seasonality should not be that much of an issue there.
And Frederik, one thing I'll add in there is many years ago, I wrote a blog post about how you could actually pass the date to an EVAR and then classify the date. Unfortunately, you can't classify the out-of-the-box reports. So if you just pass in the date, you can classify it if you have, for example, like in the US, we have kind of a seasonality around the Thanksgiving timeframe for Christmas shopping. You can then, even if the dates shift, you can classify those dates with, like, say, Thanksgiving period, and then you can then use the classification in an Adobe segment.
Yeah.
That way, Adobe will take care of some of the seasonality for you. So there's some kind of cool tricks that you can do there. The next question is, general question is, how does what you showed today differ than the anomaly detection feature and kind of the ranges that Adobe provides in their reports if you use their detection?
Also a very good question. So on one hand, it doesn't differ at all, because what Adobe does is basically look at all your historical data. I think for the last 2 weeks they do this, and then just try to find the seasonalities in the data and model that as a corridor of expected values. So basically that's just a very complex application of what we did already. But the difference is that what we are building is, or might be, just derived from our business needs. So if we have KPIs, if we have targets, we might just want to create a metric that incorporates those targets and incorporates just what we see as a business as normal and where we want our variations to be. So basically, anomaly detection is, of course, the simple solution if you're just starting up, and it's better than nothing. But if you just want to incorporate this into your business, explain it to stakeholders, and maybe change it based on your own needs, then you need to do this by yourself.
Cool. The next question is, could moving average visual and calculation be created?
Yeah, that's definitely possible. We have those functions within the calculator metric builder. I've already been thinking about putting together a nice blog post, doing some basically stock trading analysis within Adobe Analytics using some of those moving averages, which would be quite fun. But yeah, you can definitely do that.
Okay, so the next question, I'm actually going to ask it now because I might need a follow-up. Farhan had asked a question, which platform are you using while sharing the SD, please? And again, I wasn't sure if SD was standard deviation, was slide deck. I wasn't sure what SD was, so I might skip that for now. But Farhan, if you're still on, if you can maybe reply to yours or add another one with a little more detail, we'll come back. The next one is, how does the mean remain constant over time? For example, if the time range changes, doesn't the mean shift to reflect the new time range?
Yeah, sure. So sorry if I explained that in a confusing way, but yeah, it's always mean, it's always constant in the date range that you select. So it won't change unless you change your data or the date range. But once you do, then it's again stable for that selected date range.
Okay, perfect. Igor asks, any way to quickly compare how two different experiences are different or similar?
I'm not really sure.
Yeah, I'm not
what you mean
100%
by,
sure. Yeah, so Igor,
what you
if you
mean by
can add some more
experiences.
context to that question, that would be great. The next one is, can we utilize more than one independent variable while creating regression model to see which variables have higher significance on the model?
Well, that's kind of a very advanced question. So I think this is aimed at doing basically multivariate statistics. And since you have everything you need for your formula within Adobe Analytics, yes, you can do this, but it would be very complex and you need to build it completely on your own.
Okay. The next one, can we create the mean, lower, and upper limits for, say, historical data and apply that to current data or a different date range to see the number of fluctuations?
So yeah, this is basically the same that I had to do to get this forecasting use case to work. So when you're creating the metric, you can just put a segment there to select the date range that you would like to be applied to your metric. And if you change that, it will just change it, and it will not be affected by the date range that you have currently selected in Analysis Workspace. So you can just select the last year, for example, and then apply that to the current year. That works.
Okay. Well, I think so far we're out of questions. So if anyone has any last minute ones, go ahead and put them in. While we're waiting for that, I'll just kind of wrap up with a couple points. First of all, thank you again, Frederik, for joining. This was awesome. And I highly encourage you to go check out Frederik's blog where he posts really amazing stuff. Second, next week, we are going to continue on the Adobe Analytics path, and I am going to talk about merchandising EVARs. Merchandising EVARs tend to be one of the most complicated parts of Adobe Analytics from an implementation standpoint, and most people really don't understand them. So I'm going to be going through the basics of merchandising EVARs, and I had so many things I wanted to share that I'm actually breaking it into two sessions. The first one is going to be beginner / medium, and then the next one is going to be super advanced. So I highly encourage you to come join the session on Tuesday, because merchandising EVARs is the most read portion of my book and also the highest blog post that of all traffic that I ever get. So highly encourage you to do that. We did actually get one more question. Someone had said, talking correctly about R2 confidence intervals can be tricky. So is it correct or incorrect to interpret your last visualization as we can be confident that about 62% of daily increase of about 16 unique visitors, 10 per day, can be explained as the general growth trend over time, and that the remainder of about 6 per day can be explained by something else? So you might have to read that once or twice to get that.
Yeah, well, this is of course one of the, I think, the most advanced questions so far. So no, it doesn't actually work that way. So it doesn't explain any part of the regression. But what we're doing with the regression line, but I won't go back now to that slide. But basically, what you're drawing is a straight line across data that is not straight. So some of that fluctuation around that can be explained by that line, and some can't. And the coefficient of determination actually says how much of that line is explained by that. So since this is also derived from correlation, if you have just a line where 100% of your data points would be on that line, you would also have a determination coefficient of just 100%. That's not going to happen in any reasonable, realistic scenario. So this indicator really shows you by how much it goes around that line that you just created. Don't know if this answers your question completely, but I also think this is something we should discuss in detail somewhere else.
Yeah, and feel free, Frederik's got his Twitter handle out there, so feel free to hit Frederik up as well. Yeah. And we're going to take all these questions. I'm going to provide them to Frederik so he can answer in written format, and we will put we'll put that in the Slack group, as well as we will put the full recording of this session. So I think with that, I think we've run out of questions. So Frederik, again, thank you so much for sharing your wisdom, and we will post this later today in the SDE Slack group. If for some reason you're listening to this and you are not a member of the SDEC group, please email sdec@searchdiscovery.com. I can show you how to join. It's totally free. And that way you'll get access to the Slack group where you can see not only this recording, but every recording that we've ever done for all of the 12 sessions so far. And you'll be invited to all of the future ones, so you'll know exactly when they are. So again, thank you so much for joining, and have a wonderful rest of your day.